Hello, I'm Simon, also known as Polyhop. This is a special edition TouchDesigner series covering the new POPs operator while we're still in the experimental build. Today, we'll be focusing on the Extrude POP, looking at how the distance attribute can be driven by a 2D texture or using the noise pop. I also touched briefly on using PBR materials with HDRI and environment lights, so that'll make something like what we see behind me. This tutorial uses build 2025-30770. Fair warning that things will likely change between now and the official release. So my hope is that the methodology here can be recreated in the future, but there may be differences if you're watching down the line. Before we begin, I want to thank all my Patreon supporters and give a special thanks to my top supporters. On Patreon, you'll gain access to exclusive example files and tools, can vote on future tutorial topics, and more. So yeah, let's get started. So for this tutorial, I will be working with this 3D model called Stork Couple. I won't attempt the German pronunciation. This is a bronze sculpture from 1958 that's in the Vienna Water Park. I found this on Sketchfab through this CC0 collection from Thomas Flynn that collected a large range of public domain models. So I will include a link to this collection along with the link to this specific Stork Couple model. So if you want to follow along with this model, go for it. There are plenty of others that probably would work with this effect as well. But certainly this is what I'm using, so that might be the best way if you want it to be a more direct follow along. You can download the 3D model here, and I recommend using the OBJ, which is the original format. I did actually experience issues with some of these other ones, just not necessarily being as clean, so definitely recommend the OBJ in this case. And yeah, I'll include that in the project file as well on Patreon, so you can also grab it there. Yeah, let's go ahead and pull this into TouchDesigner and start taking a look at it. So here's TouchDesigner, and we can start with a file in POP, though I'll note this is not the final file in I'll use SOPs for some of this, so we'll look at that in a second. But just to show in POPs, I'm opening up the OBJ, and you can see here is our mesh. It's around 200,000 points or 400,000 primitives. So pretty high density, and if we pull an extrude pop off of this, it seems to work fine as is, right? But it's pretty dense, and the effect that I want, I don't quite want it to look like this like grass or like spiky hair, though that's definitely a valid effect, but I'm going for a low poly extrude. So I'm going to need to work with this 3D model a little bit for it to do what I want. Now, it'd be great if there was a Polyreduce pop, and maybe one day there will be, but for now, we're stuck with the Polyreduce SOP. So I will actually start with a file in SOP. So I'll repoint that to our OBJ. All right, and now our OBJ is loaded. Yeah, let's drop a Polyreduce SOP after it. Before I touch anything, I just want to note this is like definitely heavy on the CPU, and sometimes TouchDesigner will hang for a few seconds or more, and it can even crash if it's not responding or taking too long. So different systems might handle this not so well. I'll definitely include the Polyreduced file in my Patreon project files if you want to just skip this whole process, or if your system's having issues, I will provide that. And also just sometimes you have to be patient, or be careful with some of these changes. Not all 3D models are even like doable in TouchDesigner, so you might need to take it into other software like Blender or other 3D modeling software to do this work, to prepare it for TouchDesigner. So this is just what works for this model, but it may not work for every model or on every machine depending on your hardware. Okay, disclaimer done. Let's go ahead and set this up. So I'm going to use number. I actually found it harder with percentage for this one, and I'll choose wait for it to do its thing. So at every single change, I'm going to have to wait for it to calculate, which can also be a little bit slow. So this is kind of cool. It's almost like folded paper, which is definitely a look, but I'm actually going to set this to 10,000, and then I will wait for it to do its thing. Cool. Now it's a little bit like funny. Like even you can see that there's some issues with it, and especially like on the bottom, like this does not look great. So we're gonna want to dive into this clean tab, and what I'll do is I'm going to set all of these to 1, stiffen border, stiffen features, equalize edges, and I'm also going to turn on prevent cracking, though that one didn't seem to make as much of a difference. But all of these you can work with to refine the way that it's reducing the poly count. So each time I do this, it's going to hang, so just bear with me while I go through this. And that's 1, 2, and actually equalize edges is really, I think, where the magic happens. Boom. Okay, so that's almost like maybe just the one that is important here. So you could try that if the other ones are not having an effect. And then prevent cracking. Doesn't really make a visual change, but often these are the ones that I'll try turning on to clean up my model. So yeah, this is looking good. I like the degree of poly count, like the size of those triangles. You can certainly adjust the reduction to kind of play with that later. But for now, let's stick with this. I'll drop a null after this SOP, and then let's go ahead and jump into pops. So I'll use a SOP2. Looks good. And then from here, I want to do a couple things to align and center the model. So first off, I'm wanting to work with the model on the y-axis, and right now it's oriented on the z. So I'll start with a transform, and here I can just rotate it in the y 90 degrees, and then the z 90 degrees. So that gets us where we want to go. I might even be able to just do X. No, but then it's upside down. So yeah, cool. So 90, 90. And then from here, I want to normalize this since the size is like 8, 14, 6.5. So it's a little, like I like kind of keeping things to a 1x1 box. It makes it a little easier to work with. And so I will use the normalize pop. And right away, it looks pretty funny because it is normalizing each axis independently, irrespective of the original aspect ratio. We can choose aspect correct, which is a really awesome feature here. This just takes our largest axis and sets that to 1, and then the other two follow at the same ratio. So keeps everything looking correct. Now, the next thing I'll do is I want to center this as well. So the transform pop has this great align page. I find this page especially handy since it didn't really exist in SOPs. Yeah, it's just right here. You can set align, translate X, Y, and Z to origin. And now our geometry is centered nicely at 0, 0, 0. So that's it for the file prep. I'm going to go ahead and create a null here. And then from that, we can right click and save geometry. So you'll do that and you can save it as a TOG, like a TOG, or you can also save it as an OBJ. So TOG is just the native TouchDesigner format. Either one works. If you plan to use it elsewhere, I would suggest the OBJ, otherwise TOG works great. All right, now that we've prepped our file, I'm going to jump to a fresh TouchDesigner project. You definitely can save that previous TouchDesigner project just in case you want to adjust the level of the poly reduction, or if you want to process other 3D models, that would be handy. But let's start fresh for this Extrude project. Now I'm going to go ahead and create a base, and I'll call this Extrude. So this is where I'll be working today, and jump inside. And I also want to create another base inside of this, and I'll call this one a timeline loop. So since we're going to be looping everything to the timeline today, I'm going to use this to create some channels that I can reference for the timeline. I'll also change the range to 800. This will just control how fast everything loops. So jumping inside of timeline loop, I'll create a timeline shop. And I'll also include end. So I have the current frame and the ending of our timeline. And by dividing those with a math chop, I can combine channels, divide, I'll get a fraction that is our timeline. Now from here, I'll rename this. I usually rename this like fract for fraction, and I'll throw that into an out. The other thing we want in this base are some channels that we can use to loop noise. So in this case, a sine and a cosine wave that are also being driven by the timeline. I've covered this in more depth in my looping noise tutorials, so if you want more info, I would suggest checking those out. So I'll create a pattern chop. And under channel, we'll call this TXY. So I'll use T, then brackets XY to give us two channels, TX and TY. And then under phase, here I can say me.chan index times 0.25. So this is a nice way to say I want to take the index of the channel and multiply it by 0.25. So the 0th channel will have a phase of 0, and then the first will have a phase of 0.25. And if we actually add more channels, you'll see that they continue to shift in phase by increments of 0.25, which is also equivalent to 90 degrees. So that's how we can get a sine and a cosine wave with this function in one pattern chop. So I'll drop a lookup off of this with the middle mouse button to branch, and then use this as my lookup table. And now I can merge these, and I'll have some handy channels that I can reference elsewhere for looping things. The last piece I want to do, so this is even easier to grab, like anywhere in this base, is I'll go up a layer, and under common, I'm going to set an internal op or an IOP shortcut where I can just type iop.timeline and get it anywhere. So I'll type timeline, that's going to be the name of the shortcut. And then for the op, I'm actually going to reference the out. So timeline loop / out1. So I'm actually going, the dot slash goes in, and then timeline loop out1. So anywhere I want to get that, I can just say select iop.timeline, and it will select that out. So we'll use that later, but just setting this up to start so we have it for the remainder of the project. Next, I'm going to set up our full render setup. So all the lighting, all of the geometry, the rendering, just to get that knocked out ahead of time before we get into our extruding. So let's start with pulling our file in that we prepared. So I'll use the file in pop, and we'll want to point this at our low poly geo, either the TOG or the OBJ. Here we go, our reduced geometry, and we can drop that for now right into a geocomp. I'll maybe give this a name, call it birds. I wonder if I made it plural in my example. Birds, yep. And then let's add a camera and a render top, all the good things. Let's add an out. Turn on the display flag. I like the shortcuts, alt left square bracket to split left right, and then top viewer or alt 4. Give myself some space, left side display, right click here, yeah, display, backdrop tops off. And then we can also set the resolution to 1080 by 1080. Now our storks are pretty small, so let's adjust the camera a little bit. I'm going to add a null comp here, and then for our camera, we can use specify parent object, and I'll just drag null1 to both the parent and the look at. So it'll always be looking at null1, in this case the origin, regardless of where it's positioned. I'm going to set my camera translate to 1.11, so it's looking down at a little bit of an angle, but it's mostly aligned with the XZ plane since our sculpture is aligned to the y-axis. I also want to give this some rotation. By rotating the RY, I can create a camera orbit, sort of a nice way to do this with the parent and look at options. And so we can grab our timeline fract with our handy IOP shortcut we created. So IOP.timeline. And then since that is actually the out chop that we're referencing, I can grab that channel directly with our square brackets and then single quotes fract. Boom. Now, nothing happening yet because it's just going from 0 to 1, and we need to make this 0 to 360. So I'll multiply that value by 360, and now we're rotating on the timeline. Great. Now you might notice this is not lit, there's no materials, so let's go ahead and drop down a PBR material. So I'm using the physically based rendering material. It can be more realistic looking than a Phong, but it can also be tricky to get it right. When I work with PBR materials, I'm always using an environment light and then maybe some combination of additional lights. By itself, the environment light doesn't do anything because we need to provide it an environment map. These take some different forms, but commonly this will be an equirectangular format, maybe a cube map that is essentially a spherical image that's been mapped to another format. When working with PBR, it's also quite common to use what's called an HDRI, or a high dynamic range image. HDRI contain a much wider range of values to represent color and light. They tend to be 16 or 32-bit float and can just capture the intensity of light that would normally be clipped in an 8-bit image. One of my favorite spots to find HDRIs is a website called Polyhaven. So these are all public domain, CC0 licenses, which is awesome, an awesome resource. I'm using the Kiara 1 Dawn HDRI that I'll include the link to this and also include the file with the Patreon example. So you can 4K is probably fine. I think that's what I'm using in the example. Certainly 8K will work too. Probably other ones at lower resolutions, you'll have to try and see how that affects the quality. And you'll want to download the EXR format. So now that we've downloaded our image, let's use a movie file in top and point that at the HDRI. So here's the 4K version. Now you'll notice immediately that it looks a little bit different than what we just saw in that image. In fact, if I pull in the tone mapped version, this looks kind of right to your eye, and it also looks like what you might see if you were in that location. Now the original, and what we want to use, if I hit A and then N, you'll see that the values don't just go from 0 to 1. They go, in this case, 0 to 121 in the R and 65 in the green and so forth. So we have, our light is much more intense than, say, this file where if we hit A and then N, it looks more like a standard photo would, right, that we're used to seeing, where the sun eventually is clipped at 1. So we don't want to use this, even though it looks right to our eyes. We want to stick with this linear version. So that's going to be best for our environment light workflow. So I'll create a null after this and drag that onto environment map. And okay, it's doing something. That's great. Let's adjust our PBR material a little bit. So I will make the base color a little bit darker. bring down the metallic to maybe like 0.2 or so, and bring the roughness down a little bit as well to like 0.6. You can certainly feel free to play with these parameters as you like, since they'll really just affect the quality of the material and how it feels. Now, you might be inclined to just call this a day and say, hey, I've got my lighting, it looks good. And for a long time, that's how I worked with HDRIs before I understood more about linear and gamma workflows. So I'm not going to go super deep here into color space, but I think the key takeaway is that linear space has a mathematically correct relationship between light intensity and color values. So this is more physically accurate, while gamma has been mapped to a nonlinear curve that redistributes these values, and it aligns more with human perception. Linear space also tends to use higher precision values. That's why we're using 16 and 32-bit float versus gamma, which works great in an 8-bit image. So jumping back to TouchDesigner, the missing step here is we need to convert our render, which is in linear color space, into gamma. We can do this with an open color IO top. This top has quite a few features, so even beyond the conversion, I'll often use it for like a lookup table or an LUT to do tone mapping. But we just need to use the color space pre-transform and go from linear rec .709 sRGB, and then for our out space, let's use sRGB texture. So it's a lot brighter, which is interesting, but it's already looking closer to what we might expect it to based on our movie file in 2 here. I just pulled in the tone mapped image that they had as a preview on the webpage. So I'll delete that. We don't need it, but now we're a step closer to getting our color looking how we want it. So let's also add an SSAO top. This will be a lot more pronounced once we add the extrusion, but for now, I'll just dial this in based on kind of my tastes. So I'm actually going to set the sample directions to 40, but this might be kind of intense, and usually dropping this down will help a lot in terms of kind of performance. Bring up the sample steps, bring the surface avoid to like 3.5, full resolution pass. I'll set the radius to 0.08, so pretty small radius, and drop the contrast to around like 0.95, and then no blur radius. So if we turn off combine with color, we can see that it's adding some shading around the feet, around the neck, where the 2 storks are next to one another. And I'll also note that the SSAO will be a lot more pronounced once we have our extrude effect happening. So it might seem a little subtle at this point, but it'll be a lot more extreme once we're done. So yeah, last thing in this is I'll add a sphere pop. So I want to add a background color, and one way I can do that is making a giant sphere that surrounds our camera and everything, our entire scene. And so I'll make this a radius of 11, and I'll increase the frequency as well. So just giving myself more triangles. I'll drop a geo, and great. Now we have filled the screen, and we're not seeing artifacts from the SSAO. And then let's give it its own PBR material, and I will dial this in a little bit. So let's make it a bit darker, 0.2. Also bring the metallic down and the roughness down a little bit, say 0.1, and roughness 0.7. Good, okay. So that's pretty close to what I had in the example. So the next step will be to add our extrusion. All right, let's add some extrusion. So we looked a little bit at this already, but let's drop an extrude pop and see what happens. So boom, right away, it's pretty intense. It's definitely extruding much more than we want. So let's bring this distance down, and you can see it's already doing something fun. So all of our primitives in this case are being extruded from the normal, so out in different directions. And we can also control the inset, so bringing that down or up. scales that extruded primitive either down or up, right? So at 0, it's the same size as the original, but if we bring it all the way to -1, we have these points. I'll probably set it to like 0.5 for now, and this is an okay, maybe like maximum distance here. So it's already looking pretty good. You might not realize it, but the normals are not being calculated correctly in these crevices. So everything is getting the same lighting, like all of the columns are being treated as having the same normal. So it actually notes this in the documentation that we do need to add a normal pop after this. So I'll go ahead and drop one in line. It's already looking better, but I think for this low poly look, I want to use the vertex or even the primitive, they look almost identical, attribute class. So now it's basically reflecting off of each surface, and it gives us that kind of faceted look. So also you'll notice that the screen space ambient occlusion is working correctly now. So the crevices are showing up as darker, as we would hope they would. So cool. So yeah, this is already fun, but what if we want to vary the extrusion across the model so it's not all getting controlled the same? So there's this use distance attribute, and we can turn it on and click this drop down. It's like, oh, there are no attributes it's letting us choose. If we middle mouse over our original pop, we see there's a point attribute P for position, vertex attributes like normal and texture coordinates, but none of those show up in the extrude pop. When I was first working with the extrude pop, I wondered why I couldn't find any attributes, and then after thinking about it a little bit, I realized that they must be primitive attributes, which would also make sense because it's the primitive that is being extruded. So let's go ahead and set up some primitive attributes to control our extrusion. I will collapse my extrude and my normal here, right-click, collapse selected, and kind of do all of my extrude effect in a base, just in case I wanted to reuse this later. Call this extrude. We'll look at two different approaches today, and the first uses a 2D texture in tops combined with the lookup texture pop. When sampling a 2D texture, we need at least one and maybe even two channels as our UV coordinates. We can get these in a lot of different ways. In this instance, I want to use position, so we'll need to choose two axes as our axes to sample the texture. Before we use our position as a lookup channel, we'll also want to process it so it goes from 0 to 1, or normalize it so it works as a UV lookup. So to do this, I'll right-click and add a normalize pop. And we don't want to normalize the size, like we don't want to actually apply this, but we can set our attribute scope to normalized position, or I think I set it to position normalized, POS normalized. So that's cool. We have that as a new attribute instead of overwriting it. But we also want this to be in our as a primitive. So I'll set this to primitive, and then it's like, oh, wait, you don't have a position attribute as a primitive. So we also need to, before our normalize, use the attribute convert. So here is where we can say we're actually going to convert from point to primitive, and we want to choose P. And then let's turn off delete original so that we don't delete our point attribute, which it needs to actually draw our geometry. Otherwise, it just like deletes it. So now we have duplicated that as a primitive attribute. Great. Okay, and now our normalize is happy. So we have position normalized as well. And we'll use that for our ramp. To keep things more organized, I'm going to use separate bases for the different methods that we're going to be using. I can start by creating a lookup texture pop, and then I will right-click and choose collapse selected. And I'll go ahead and name this something ramp distance attribute, abbreviating distance and attribute. Jumping in here, now we can give ourselves a little bit of space move back towards the origin here, and I'll drop a ramp down, a ramp top, and I will set this to 1080 by 1080. And usually when I'm using like ramps for animating values, I will set the pixel format to at least 16-bit float. Now for our purposes, I want this to kind of have like a burst that kind of like moves through the shape, through the model, but like not affecting it for most of the time. So we'll bring like, and I also want there to be a kind of base extrusion for the whole entire ramp. You can play with this, quite a bit, get different effects, but for now, that's what I'm going to set this as. And then I will also set this to ease in, ease out. So it gives us like an ease shape as it extrudes the geometry. I'll drop this into a null. And then for our lookup text, drop that onto the top. We're going to want to use an output attribute scope, call it distance. And we only need this to be a single channel. So I'll mask everything except the red channel. And we also want to make sure we're using the right, not only lookup attributes, but the attribute class. So I'll choose primitive here, and then I will use position normalized. In this case, let's choose our y-axis for U. Or no, that's the z-axis, sorry. Z-axis for U and y-axis for V. And then for our extrude, let's look here. Now we actually see our distance and something's happening. That's cool. So let's go back into our lookup texture. A couple of things here. Let's make sure we set hold for our input extend mode. We don't want it to kind of sample the edges and be weird. And then I'll also add a transform to rotate this in a second. But first, let's animate this because we want to be able to see what's happening. And actually, we already see it is working. Very cool. So let's go ahead and animate this with our iop.timeline. And in this case, I will also choose fract, basically the same thing we used to animate our camera. I'm also going to multiply this by, say, like, I don't know, -4, -3 maybe, make it a little bit faster. And then I also want to make this a vertical. Just, it'll be a little easier to see what's happening if our, we want that to be a top-down motion, and that's partly what I did here. Is choosing the, the Z and the Y being the lookup V, so it kind of coordinates. If we wanted to change, right now changing this to X or Z doesn't have any effect, but it will if I do something like rotate our ramp to give it kind of like a diagonal, so it's moving like left to right a little bit as well. Now, I need to make sure I also use repeat for our extend mode, and that looks better. So now we're getting this kind of cool like ramping effect that goes top to bottom and also left to right a little bit. This rotate will certainly affect like how much is it going left to right versus top down. So I think I had it to like 20 something. So it's mostly a top down effect with a little bit like starts at one bird, then gets to the second bird. So I also want to mask the base of the statue because I like that when that stays static and it's just the birds that are being affected. So I could do that in here with the same lookup, but because I'm going to look at another approach as well, and I always want the statue base to be masked, I'm going to do that as a separate lookup. So I'm going to copy and paste this same setup, and it's not going to be happy immediately. I'll delete the transform and the animation here. And then let's also remove the face. And then I will give myself what I imagine to be the right position. I might have to adjust this a little bit, but I want, because I'm using the y-axis as my lookup attribute V, then I will treat this as a mask that I will multiply by our distance. And so instead of this being distance, let's call this distance mask. And I'll also add a math mix. And here I need to make sure that I set my attribute class to primitive, and then in combine, multiply A times B, and it'll multiply our distance times our distance mask, making sure the result scope is also distance. I think that we're not seeing anything because I didn't combine it. So let's actually call this like mask dist. Okay, not quite working yet. So let's see what's going on. Oh, it's not totally 0. There we go. That looks better. So yeah, we want to make sure that these values are 0, and then we can bring our stops so that they kind of line up with the feet. So, you know, the more you create this, pull these stops out, like I could make it so the feet are affected less, or the head, or things like that. This might have to be different if you have a different idea in mind, like however you can think about sculpting that mask really depends on the specifics to your model and the effect you're after. But this is what I wanted, where, you know, the base isn't affected by my my ramping extrusion effect. All right, so now that we have our ramping effect, I also want to show how we can just use noise that doesn't use the lookup texture to create an effect. And then we'll also look at how to mix those two together. So let's pull our ramp distance attribute base up, and with the middle mouse button, we can create a new base that branches off. And I'll call this noise dist attribute. Now, inside here, let's go ahead and add a noise pop. And right now it's just displacing things. But a couple things here. We need to make sure that our attribute class is primitive. We want to go to the output. We don't want to combine anything, so I'll turn that off, and then I'll set my noise to distance. Now let's adjust some of these noise parameters. The seed, this is really just if you want to change the quality of it later, so it doesn't really matter for our purposes. We'll set the period to 0.5, harmonics 1, so that it's not going to be quite as dense, and then the amplitude, let's make that 0.6. We'll look at this in a second, how this appears. Actually, I can pull this right in, and it's not happy because, oh yeah, it's not happy because our noise attribute should be a single channel, so we need to set our noise size to 1. Cool, so that's interesting, and actually it's kind of fun when it goes negative. It's not the effect I'm interested in, so I'm going to limit it, but you definitely could play with that kind of flip between the positive and the negative distance where it gets like, you know, inset. Now I'm going to limit it, so I'll go ahead and add a limit pop, and then we'll set a clamp. And so I could set this to 0. Oh, this is the position, hilarious. Let's make sure we set this to primitive, and then also our distance. And so now we've clamped it at 0. I like it to be kind of like 0.2 or so, like I did with the other one. You have a little bit of a minimum all the time, which I like the way that adds some like additional shading with the SSAO. Now, this is cool. We already have like some noise affecting it. So I want to also transform this using our channels that we created on our timeline loop. So I'll go ahead and drop down a select chop. I'll do iop.timeline and set that to expression. And then we can choose TX and TY here. I'll drop a math chop after and then a null. So this will be how I control the like intensity of the animation, like the speed rather. And then I'll go ahead and export these to TZ and translate 4D. Cool. So we've got our animation happening. I think I'd set my mult add to like 0.8, but that's definitely your taste. Like if you set this up really high, this multiply, you'd get a really fast animation of the noise, and additionally, like all sorts of things with the period. If you increase the period, you're going to get bigger sections of similar extrusion versus like if you want it to be sporadic. It's also a very cool effect, actually. Bring the period way down. So yeah, a lot you can do with just this period adjustment. I think let's go back to 0.5 where I had it. We might also want to combine these so they're like blended together. And this is something I only learned recently, is that the switch pop has a built-in blend, which is like awesome. So you don't even need to use the blend pop if you want to just blend between two sources. So what I'll do is drag these together. So now we have our ramp, our noise, and if I choose blend between inputs, we can get a smooth transition between our noise and our ramp-based distance attributes. Or we can set it to 0.5 and get a 50-50 mix. One additional thing we might do is jump up a level and expose some key parameters on the extrude base so it can be more reusable, more of a tool that we can drop in and play with other inputs. So if I wanted to say, pull some of my favorite parameters, like I might want to drag in this index, bind pair as new master. I'll want to rename that something useful, like we could call this, I don't know, blend. I might have called it something different. I think I called it method before. Yeah, blend. This could be also useful to pull in the distance and the inset. Reorganize those a little bit. So now if I go to the top, I have some ways to say control how extreme the effect is. I can control the inset from here, the blend between the different modes. So yeah, it gives a lot of different options right at your fingertips, so you don't have to dive in. So certainly anything else that you like to play with, you might pull all of those noise attributes up either to this level or all the way to the top. And there you go. That's our extrude effect. I also want to highlight how easy it is to plug in different geometry and explore this extrude effect. Here I'm taking the sphere that we used for the background, bringing the radius back down to something like 0.4 or 5. And you can see we immediately get something different, a fun generative system that we can play with further. I definitely suggest exploring it with found geometry, things that you've created in other software, things that you've created in TouchDesigner. There's a ton of opportunity to use this in different ways. So I hope you learned something, maybe about pops, maybe using the Extrude pop for the first time. And yeah, thanks so much for watching. Hope you enjoyed.